You ever get that feeling that probability just doesn't make any sense? Well, it's not just you. It turns out our brains have these little built-in bugs, these cognitive glitches, that make us surprisingly bad at wrapping our heads around statistics and chance. So let's kick things off with a classic puzzle that shows just how deep this glitch really goes.
All right, we're going to start with a fun little thought experiment. It seems totally straightforward on the surface, but it's a perfect example of how our intuition can just lead us completely off a cliff when probability is involved. So, picture it. You're at a small get-together, just 23 people in the room. What do you think the odds are that at least 2 people there have the exact same birthday? Now, most of us would guess a really low number, right? Maybe 5%, 10% tops. What's your gut telling you?
Get ready for this. The actual answer is an incredible 50.7%. Yep, you heard that right. In a room with only 23 people, it is more likely than not that 2 of them share a birthday. It's basically a coin flip. This is called the birthday paradox, and to most of us, it just feels completely and totally wrong.
And that feeling right there, that "no way, that can't be right" feeling, that's the whole point of our explainer today. This isn't just some quirky math problem. It's a window into a fundamental flaw in how our minds see risk and chance in the world all around us. So, what in the world is going on in our heads?
So this glitch actually has a name. It's a cognitive bias that messes with everything from our biggest fears to the tiny decisions we make every single day. Let's really dig in and diagnose this blind spot.
And here it is, the core of the problem: probability neglect. It's a fancy term, but all it means is that when we're looking at an uncertain outcome, especially one that gets our emotions going, like fear or excitement, we kind of just toss the actual numbers, the actual odds, right out the window.
In other words, we fixate on the what instead of the what if. We get totally hung up on how good or bad the outcome might be, the magnitude of it, and we pretty much ignore how likely or unlikely it is to happen in the first place.
And this isn't just a theory. It's been tested. In one wild study, researchers found that people who had a 50-50 shot of getting a mild electric shock were just as anxious as the people who were definitely getting shocked. The brain just heard electric shock and hit the panic button, completely ignoring the 50% probability.
And you see this play out in the real world constantly. We hear shark attack, and we picture this terrifying, vivid scene. So we blow the risk way out of proportion, even though it's incredibly rare. But at the same time, we'll get in our cars every single day, which is statistically way, way more dangerous, and we don't even think twice. Our fear gets completely disconnected from the actual data.
Now, probability neglect isn't the only trap our brains fall into. There are a couple of other glitches that come from this same blind spot. And to see one, let's finally solve that birthday puzzle.
Okay, so here's the secret. The reason we get the birthday problem so wrong is that we're asking the wrong question in our heads. We think, what are the odds that someone has my birthday? But that's not it. The real question is whether any 2 people in the group match. And for that, you have to look at every single possible combination of people.
In a group of just 23 people, there aren't just 23 comparisons to make. There are 253 unique pairs. That's 253 different chances for a birthday match to happen. When you think about it that way, a 50% probability starts to sound a lot more believable, doesn't it? This whole idea of not seeing the full picture leads us to another crazy glitch called Simpson's paradox. This is a total mind bender where a really clear trend in your data can completely flip on its head when you combine it or look at it from a different angle.
Okay, check this out. This is from a real medical study on 2 treatments for kidney stones. Now, if you just look at the overall numbers, treatment B looks like the clear winner, right? 83% success rate versus 78% for treatment A. So if you're the doctor, you pick B. Simple.
But wait, when the researchers broke down the data by the size of the kidney stones, which is a really important piece of context, the results completely flipped. Treatment A is actually better for small stones, and it's also better for large stones. So how on earth can it be worse overall? That doesn't make any sense.
The answer is something called a lurking variable. In this case, it was stone size. See, doctors were more likely to give treatment A, which was more effective but also more invasive, to the patients with large stones, the really tough cases. Since treatment B was used more often on the easier, small stone cases, its overall success rate got an artificial boost. The combined average was telling a lie.
So we've seen the glitches, right? We ignore probability, we get confused by how things are grouped, and we get totally fooled by simple averages. It kind of sounds like our brains are a mess. But what if there was a simple software patch for our thinking? A mental tool that could help us see right through all this confusion?
Well, there is. It's called a natural frequency tree, and it sounds complicated, but it's not. All it does is help us stop wrestling with confusing percentages and probabilities, and instead translate them into simple, concrete numbers our brains can actually grab onto and understand. Honestly, the best way to see how powerful this is to just walk through an example. So let's use this tool on a real medical scenario where getting the probability right is, absolutely critical.
Okay, so here's the problem. Let's say we know that 10% of patients with certain risk factors have sepsis, and there's a specific symptom that shows up in 80% of people who have it. So if a patient walks in with that symptom, what's the chance they actually have sepsis? Our gut screams 80%, but let's build the tree. Start with a nice, easy group of 100 patients. We know 10% have sepsis, so that's 10 people who have it and 90 who don't. Easy. Now let's look at the symptom. Of the 10 with sepsis, 80%, so 8 of them, will have the symptom. But let's also say that symptom shows up for other reasons in 10% of the healthy people. So that's 9 people without sepsis who also have the symptom.
Now we can just lay all this out in a super simple table. These aren't confusing probabilities anymore. They're just counts of actual people. We can clearly see exactly who has the symptom and who doesn't.
So, to find our answer, we just have to look at the people who have the symptom. In total, that's 17 people. The 8 who have sepsis plus the 9 who don't. And out of those 17 people, only 8 actually have the disease. The math is suddenly ridiculously simple. It's just 8 out of 17.
And that comes out to just 47%. Not 80%. It's not even close. By turning those tricky probabilities into simple frequencies, we completely sidestepped our brain's natural glitch and got to the right answer. That's how powerful this is.
So, thinking this way, thinking in frequencies, is like a superpower for correcting our faulty intuition about stats. It helps us see what's really going on behind the numbers. And that brings up a final thought. If our brains can be so easily tricked by something as simple as a birthday party or a medical statistic, what other big decisions in your life are being quietly influenced by these hidden glitches every single day?